1 minus 1. These are 2 1s and 2 minus 1s. This is 1 minus 1 minus 1 1. Okay. Now how do you generate the code chips? Okay. There's something called Walsh matrix, and we are going through that Walsh matrix also, and we'll see how the code chips are generated depending on the number of users that are there, and make sure that each one is orthogonal to each other. Okay, so these are 4 chips, and let's see what happens. Okay, so data bit, if it is 0 and you multiply that, okay, so before you send the data there, you're going to convert the data also into a tri-state value. Okay, why tri-state? We have data could have value 0 or 1, bit could be 0 or 1, but we could also have silence. Okay, so we want to encode silence also. So in order to be able to do that, silence is encoded by a 0. Okay, so bit value, if it is 1, we put a plus 1. If bit value is 0, then we put a minus 1. That's another very important thing. Also, your code chips are 1 and minus 1 values. Is that? So when you multiply, minus 1 will give you a 1. Okay, so that power is exploited here in code chip by going ahead and representing your bits not by 1 and 0 but 1 and minus 1, and that also creates room for silence to be coming in as a 0. Questions? Okay, so you have your bit 0 that comes in, and you code it as minus 1. Again, this is bit 0, this is bit 1, and you code it here as minus 1, and plus 1, and then you have your 0, which is representing your silence. Okay, so the first chip, as we saw, this is decided as 1 1 1 1, right? So we go to the first top one, that station is allocated the chip 1 1 1 and 1. Okay, so you take this one minus 1 and multiply with that. Okay.